So the steady state vector W will have three components because this is a 3 by 3 matrix. So I will write like this. So W equals W1, W2, W3, because this is a probability vector as well. So since it's a probability vector, so this three components should, the sum of these three components should equal to 1. And then, so this is for this stochastic matrix. So if W is a steady state vector, then A times W should equal to W, right? So I'm just going to multiply. I'm just going to multiply this. So I'm just going to put here W1, W2, W3, and that's going to equal to W1, W2, W3, right? And notice, because this is a stochastic matrix, so the sum of the columns is exactly 1. So then I'll just write this. So I'll just multiply this out. So it will be 0.1 times W1 plus 0.2 times W2 plus 0.3 times W3 will equal to W3. And I also have this equations here as well. So, and then I have the second equation is W2, 0.2 W1, 0.3 W2, and then 0.4 W3 equals, sorry, this is W1, this one is W1, this is W2, and then 0.7 W1, 0.5 W2, 3 W3 will equal to W3. And then plus this equation, like I said. So this is what we can do. So you can just kind of, okay, so if I just subtract 0.1 right here from both sides, then I'll get 0.9 on the other side, right? So, or you can just move it to this side, so it doesn't really matter. So what I will do here is now I will just make this so okay, so negative 0.9 W1 plus 0.2 W2 plus 0.3 plus 0.3 W3 equals 0. And then similarly, the second equation, you can just subtract W2 from both sides. So this will be 0.2 W1 and then minus 0.7 W2 and then plus 0.4 W3 equals 0. And in the last equation, just subtract W3 from both sides. So this will be 0.7 W1 and then 0.5 W2 and negative 0.7 W3 equal to 0. Okay, so and then you just have to solve this system. So to solve this system, it's a homogeneous system, so you can actually just create a matrix and solve that matrix if you want to, or I can just maybe like yeah, it's probably just better write this as a matrix and just reduce it to row reduced echelon form. And each one of this is like 0.1, so it has one decimal place, so you can just convert it to regular number, right? So it would be like 9 W1, 2 W2, and then 3 W3 equals 0, and then this is 2 W1 minus 7 W2, 4 W3 equals 0, and 7 W1 plus 5 W2 and minus 7 W3 equal to 0. So this will be corresponding to this homogeneous form. So negative 9, 2, 3, 2, negative 7, 4, 7, 5, negative 7, right? And then just solve this. So when you solve this, we should have a unique solution actually. So let's see. Okay, so just solve this. So basically reduce this find the row reduced echelon form, okay, and then the solution that also satisfy this equation. So you need to make sure your W2, W1, W2, W3 satisfies this equation as well. So what we did, so basically this is the steady state form, and we just have to find the vector W from here, which I just write it like this, and then I just kind of reduce it and solve this system. But you really need to, you know, find this. So row reduced echelon form. So and then pick up the solution that satisfy this criteria here. So that's basically it.